Direct and inverse variation. In a direct variation, let's say we're looking at x and y. Let's look at a graph. And the x-axis is here, the y-axis here. In direct variation, as the x's increase, the y's will increase. So any graph that has that type of look where they both are increasing, as one increases, the other increases, you have a line that looks like this. Another example of x and y both as x increases, y increases could be a nonlinear. Okay, this is another example of what you would see as x increases, y increases. Now, in an indirect variation, when you look at x and y, what you'll see is a graph that as x increases, y will decrease. Okay, so a line will look like maybe this right here. As x is increasing, y is decreasing. You can also have nonlinears where x increases and y decreases. Um, there's a nonlinear right there. Okay, so the question is, how do you create these direct and indirect variation equations? A direct variation versus the indirect variation will have the form y equals a constant times x. Or it could also be y equals constant times maybe x squared. Or maybe y times k times a x cubed. Just anything where you have this type of combination. Whereas the inverse, you'll have y equals k over x, and that'll give you an inverse variation where as the x increases, y will decrease. You can also have a constant over x squared, and maybe even a constant over x cubed. But again, it'll have the same look where the constant is multiplying here and the x is multiplying. And over here, the constant is multiplying, but the x is dividing. Okay, so let's take a look at these questions. A distance varies directly with the speed. So just from this one right here, just from this part, the distance varies directly with the speed will be d equals k and s, where d is your distance and s is speed. And everything is multiplying the k and the s, so it means this is a direct. Now, furthermore, it says the distance traveled is 150 while the speed is 60. So that means that we can put in 150 substitution for d and put in 60 as a substitution for s. And that's our next step. Now, I can use this right here, this information of 50 and 60 to actually solve for k. So I'm going to pause here and find out what that constant is that they're using. So I'm going to take 150 and equals k 60 and divide both sides by 60. This will give me, the zeros will cancel. I end up with a 15 over 6. I can divide both of those by 3. And that'll give me 5 over 2. So my k is 5 over 2. Okay, so what I actually now have is d equals 5 over 2s for this situation here. The question now is, what is the distance be if the speed is changed to 50 miles an hour? So using this new equation, let's change the speed to 50, and we'll get 5 over 2 times a 50. Now, 5 over 2 times 50. Oh, let's bring that down a little bit. Sorry. Let's see. If I make that 50 over 1, this will be d equals 5 over 2 times 50 over 1, which is 250 all over 2. It's a bad looking 50. And that will simplify to 125. And everything was miles per hour, so distance will be just miles. Okay. All right, let's do another one. Here we have the area of a circle varies directly with its radius squared. The area of a circle varies directly with the radius squared. So that's area equals, there's the k right there for the constant. But instead of just r, this is going to be r squared. Okay, so this is direct variation equation for this right here. Now they tell us that the area is going to be 28.26. So 28.26, while the radius is going to be 3. So k is unknown, and we're going to replace this with a 3. Now, 3 squared is 3 times 3, which is 9. So this is 28.26 equals k times 9. And then we'll divide both sides by 9. And we find here that k is, let's see, 20. 9 goes into 28 3 times, leaving a 1. So 9 goes into the 12. That'll be left over 1 time. And then there'll be 3 left, which is 36. And 9 goes into 36 4 times. So the constant that's being used here is a 3.14. So a equals 3.14 times the r squared. Okay, we just use the information to find the constant. Lastly, what would the area be if the radius was 2 centimeters? So area equals 3.14, 2 to the second power. And from here, we'll get a equals, well, 2 to the second power is 4. So this is 3.14 times 4. And I will multiply that. Let's see, 4 times 4 is 16. So I get a 6 here. 4 times 1 is 4, plus 1 more is 5. And 4 times 3 is 12. So that'll be 12. And the area is measured in centimeters squared here. So we'll say area is centimeters squared.